Oh no. All right, let me see. 72H. All right, so here's the problem with linear correlation. Does the data we are given, holy crap, does 6 stories, does it live inside of the data range that we're given? The data range we're given is 6 in here. How else can I say that? Does everybody see the range of data we're given? These are the stories that we're given. Is 6 inside of that data range?
No.
No. So your line cannot say anything definitive outside of the range of data it works with. That's really exactly, if you tracked a fish from when it's born to, and you just watch how much it grows, and then you stop watching it, but you let the equation keep going, you're going to be like, oh my God, that fish is going to eat the earth. No, dummy. At some point, it's going to stop growing, and your line of best fit is not going to work anymore. Right? So it only works within the data range that you have. Does that make sense? So that problem says, what's the estimated height for 6 stories? So plug 6 in, see what you get. You might get something weird. And why might it be weird? Because it's outside of the range of data that it was built on. Does that make sense? Okay. All right, so let's see. I think I heard somebody else come in. So as you guys come in, let me know if you have any questions. 72 is a popular one. Oh. Okay, everybody's okay? Everybody's good? You guys, did you find some time to get caught up on homework? Apparently you did, because I have a ton of stuff to look at suddenly in chapter 12. Okay, so if there's no other questions, we're going to go right into a little review. Let's see. Our next quiz is this Wednesday. And then, of course, why is Monday special? Anybody know?
Is Monday the final?
Monday is not the final. Good job.
Review session.
Yes. What else is special about it, though? Why is the review session on Monday? Say again?
Isn't it our last day of class?
Last day of classes, all across the board. You don't have any more class after that day. After that day, you have finals. Finally review, yeah. Yeah, Jeff, you never review. Finally, we're going to have a review. I think, did I put the practice final up? I did.
Yeah, you did.
I did. Yay, look at me. So if you go into Canvas, you'll see up here the practice final. Da, 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 da. Oh, it's so awesome. It's so long. It's so kick-ass. Look at that. That's awesome. And of course, it's got a problem we haven't done yet. So we're going to do that, more of that today. I think we might have done a little bit of this. I can't remember now, to be honest. Let me think. Was there anything else in here I needed to show you? I don't think so. So yes, I got the practice final up there on Monday. We'll talk about that. Wednesday, this Wednesday is our last quiz, and it's going to cover correlation, right? So I do have like a practice problem. I don't think we did it yet, so we can do it. You have to tell me if we did it already. It was the one that's what I wanted to show you. So if nobody else has any other questions, we're going to look at the little practice problem I've got. Hopefully we haven't done this already. We'll find out. So if you go back to modules, you go down here to, where is it, Jeff? Unit 11. Yeah, of course I didn't, because I haven't put this up here till just now. There's this goodness of fit thing. So we're about to talk about this, but on the other side of this, there's a correlation regression practice problem. We haven't done this yet, right? I don't think so.
No, we didn't.
So again, if there's no more specific or general questions, I want you to start trying to do this problem. Right? Throw these into list one. Now listen to me. Let's see if you guys can handle this. You don't need to make these decimals, but you can if you want to. Your decision is going to impact what you're going to do down here for this problem. So let's all do the same thing. Do not make these decimals. Put them in exactly like this. You guys with me? So that we all have the same numbers. So I'm going to do it in my calculator here. Let me pull you up. Where are you? There you are. Oh man, I lost somebody. And all right. Here we go. This is going to be an exciting part of the recording. Oh shit. You guys have run into any difficulties or have any questions while you're doing, let me know. If you are just joining us, we are putting this data in to list one and list two. We're going to do a correlation study on this. Oh shit. Is that annoying if I do that? All right, let's see. I think I got it all in there. Oh, okay. Damn, Massachusetts. Calm yourself down. Let's see. No one will be seated during the action-packed entering of data scene. The worst thing in the world is to get to the end in list two and the lists aren't the same size. Has that ever happened to anybody? And then you're like, what did I forget? see down here, this is what I'm going to give you on the quiz and on the final is I'm going to tell you what R has to be bigger than or less than if it's negative to show evidence of correlation. Remember, it's got to be close to 1 or -1 to be strong, but there's another number that it's got to get past just to be evidence that there's correlation at all. It's got to be far enough away from 0. Has everybody got all the data in there? Have you guys, anybody still doing the data? All right. I'm going to stop sharing this. I'm going to share my calculator. Get over here. Calculator. Bam. Now, what buttons do I push just to make the scatter plot show up? Oh, okay.
Zoom?
Yeah, okay. Now, I probably have to do something else. Let me check. I might have turned my stat. Yeah, I do other stuff with it. So I turn my stat plot off. Ooh, I got a chat from somebody. Zoom stat, I like it. So Zoom. And for me, it's number 9. I like it. If you have other stuff showing up, or if you have an error, very often it's because you have stuff in the Y1. Oh, my Y1 is weird. Hold on. See, I have an old thing here. Bam. I got a chat. Let's see. Are we doing decimals? Yes. Oh, wait a minute. What? No. So like I said, you understand? These are percentages. So all I said was don't make it like 0.281. Don't make it into pure decimal form. We just left them as percentages. Is that all right, everybody? Hopefully everybody did that. If you didn't, you're just going to get some, your decimal will be off. You'll see, hopefully, if anybody did that. So now what do I push to figure out the R value and the line of best fit? Somebody else tell me. Where do I go? This is your chance to tell me where to go. Sorry?
Stat. Scroll over to calc. Hit 4.
4. And then there's my X's, there's my Y's, and we'll just bypass that dude for now. Bam! That was a little loud, sorry. Does anyone have this missing? Everybody's good? So everybody was here last time? All right. What's the slope of my line? Interesting. Somebody else? Hello? What's the slope of my line?
A.
True. And what is it?
157.0.7.
I like all that. Neat. All right. And then, of course, the y-intercept is going to be this bad boy here. Right? So let's go ahead and put that in there. What is this? 1570.74. Oh, shit. You guys are going to have to help me. 1570.74x. There's your X button. What was it now? 12231. Is that right? Oh, Jeff. Point something?
0.469.
Dudular. So
69.
I did it my way. 0.469?
Yeah, 469.
All right, there it is.
On it.
Now, sorry. Now, if I just hit graph, I'm golden because it's already zoomed in. So does that look like it's in the right place? So if you see something like this, hold on. I thought I could be sneaky. Well, let's see, not even that. That's too much, Jeff. If you see something like this, let's say, that's difficult to tell. Oh man, that would be evil. But let's make it even better. If you see something like this, man, that's a little bit better. Can you guys see that that's off? How can you tell that this is not quite right? Oh, okay. Let me take care of this. Hold on. Does it give you more specific information, Catherine? What kind of error? Does it say syntax? Does it say go to? It says syntax. Does it say go to? So you want to go to. You want to pick go to, and it'll put the cursor on the problem. So what is the cursor on if you select go to? Is there something in Y1? Is this in Y1? Let me make this the right thing again. All right. Well, there's an error there somewhere. So normally the cursor goes right on the problem. All right, you got it? Okay. All right, cool. So that's that. Let's go back to the page. Let's see what else I asked you to do here. Everybody's okay? Everybody's got this bad boy? You're going to have to be able to do this for the final exam. And obviously for the quiz. And then take a copy of it, take a screenshot of it or whatever the hell. Whatever you kids do nowadays. Let me see. Where did I put this? There it is. Let me bring this back up. So then you would write in your Y. You put your R there. What was the R? Was the R good?
I got 0.924.
Yeah, okay. Is that a good R?
Yes.
Yes. Why? Two things.
It's strong.
Say again?
It's strong, like a strong
Why?
correlation.
How?
It's in the 90s. One
Close
is the
to one.
strongest.
Close to 1. So the first thing is there is correlation because it's greater than 0.482. And the second thing is it's strong what?
Positive.
Strong positive correlation. Kick ass. And why does that only make sense? I mean, why is this kind of a silly study in a way? And then I'm going to turn that on its head. Do you guys understand what's happening here? Why should we expect these to be correlated? What is it we're studying here? What should happen as the people, more and more people have a bachelor's degree, at least?
The income should rise.
Yeah, they should be getting better jobs. But what else could explain this relationship? What about the other way? What are you able to do if you have a lot of money?
Pay for school.
Pay for school. Holy shit. So there could be a little bit of both, right? It could be you're making more money because you got a higher degree, but you could be you're getting a higher degree because you're making more money. So, I mean, there's probably a little bit of both. Probably a little more having the degree, getting a better paying job, right? All right, I'm with you guys. Does this mean that if I suddenly gave a bachelor's degree to everybody in my state, the median income is going to go up?
No.
Hell no. We don't have a clue, right? This doesn't have anything to do with making a change to the data. Because what this does, now be careful, listen to me. What a correlation study does is it takes a snapshot and it sees if there's a relationship. It doesn't say anything about, well, what if I changed this? That's not what it's built to know. It's not built to know that. That would be a different kind of study. So that's sort of like part D right there. Now look at part C. How would you do part C? Anybody?
We would get the equation that's y equals ax plus b, and we would put in our variables with 37 being x.
Yeah, 37.6. I like it. So let's try that. Ooh, I got a chat. Yep, there you go. Somebody else said the same thing. I like it. So let's see. Let's try it out. Where's my calculator? Calculator. There you are. So we can either do this thing. I think I showed you this thing, didn't I? Second calc value, 37.6. Bam. Or you could put it into the equation. What was the equation again? There we go. 1570.74 times 37.6 plus 12,223.1.47. Look at me remembering numbers. There we go. Same thing, I think. Right? You guys doing all right? May you repeat the first thing you did. Oh, shit. I don't know. Yes, I can. So go back to my graph. If I want the calculator to tell me the value of any input, tell me the output for any input, I can hit second trace to go to calc. I want to calculate a value on my line. I want to calculate the value for x equal 37.6. Bam. What does that mean? Does it mean anything? Is it just a bunch of numbers? What do these numbers mean? The median income, if what? For what situation? That's the median income for a state where what? You could do it.
37.6% have a bachelor's degree.
Beautiful. There you go. And let's check that out. Does that match up with a state like Virginia where that's true? At least for the year that I got this data. I can't remember. It was probably from the 2010 census. I got to I'll get some new data. So look here for Virginia, 37.6. What's their median income? 71,535. That's pretty damn close. Right? Why was it so close? Why is that such a decent approximation? Why is that a pretty good approximation? What did we calculate that tells me this line will do a good job of approximating the answers?
The strong correlation.
The R value, kick ass. That tells me it's strong. If we would have gotten an R of 0.5, stay with me now. If we would have gotten an R of 0.5, is that evidence for correlation?
Yes.
Yes. But is it strong correlation?
No.
Hell no, it'd be weak ass correlation. I would still use the line to estimate the amount, but I would understand that it would be a bad estimate. It's a better estimate than just guessing the average of all the median incomes, but it's still not a great estimate in that case. Do you guys understand? I think you do. The closer R is to 1 or -1, the better the approximations are using the line. Okay, that was interesting. So that's sort of a boring example, but I like to do stuff like remember when we had like football games? I would do like the defense for a team versus the percentage of games that it wins to see what the correlation is. And then I would tell you the correlation between offensive yards and the games and tell you which one is a better predictor for a team to win more games. And to be honest, it's not always one or the other. Some years is offense, some years is defense. That's the better predictor. Are you guys semi with me at all? I also do other things. I do stuff like very controversial things, like maybe stuff related to elections and things, and percentage of people that have certain kind of degrees versus percentage who voted for certain people. Anyway, moving on. I like to get in trouble. Good trouble. All right, so let's talk about this weird shit today. Any leftover questions on this? This normally is kind of
Scaredy cat.
What is it? Sorry. Everybody good? All right. This normally is something students don't necessarily enjoy, but it's a nice thing because a lot of it's done in the calculator. It's visual. It's got very simple algebra in it. So normally students can latch on to it better than some of the other stuff we've done. All right, so if there's no more questions, this is what the quiz is going to be on. It's this stuff here. And like I said, I will give you the R value required to show correlation, okay? So let's get back into this kind of stuff up here. Oh, I got to chat. Oh, let me see. D, well, no. Yeah, did we finish this question? Do your results mean that if you got more people in a state to earn a bachelor's degree, then the median income of the state will increase? Is that what your results mean? We already answered this question, but just let's see if anybody was paying attention. Do your results mean that if more people got a bachelor's degree just all of a sudden, then the median income of that state will increase? Is that what that means?
No.
Nope. Notice I'm not saying that it won't. I'm saying, do we know if it will from what we studied here? We do not know, which is always a beautifully acceptable answer. I don't know. So you can't say no, it won't, and you can't say yes, it will, because we don't know. What's happening? Wednesday's the quiz. Wednesday's our last quiz. Monday is the review for the final. Is that cool? And the practice final is up on Canvas. So that'll be part of what we discuss on Monday. Are you guys all with me? I think the final, when is the final? Is it on Wednesday?
The 9th?
Yeah, that's Wednesday. Okay. Here we go. There it is. Wednesday the 9th. So it'll be during this time on Zoom, everybody's camera on. It'll be an exciting time. See if all of our broadbands can hold it, keep it together. Everybody with me? Exciting times. Okay. All right. So let's get back into where we left off, unless there's any other questions. Any other questions out there? Okay. All right. So just to remind you guys, let's remember this new chart. Oh, yes. If you missed last time, you're going to want to take a look at the, what do you call it? The video. We got another chart. This is the last chart of the semester. How do you say this?
Chi-squared.
Beautiful. And that's what that little dude is. That's the Greek symbol chi, right? I made my requisite Dragon Ball joke. It's not about the Kais from Dragon Ball. Don't get too excited. How the shit do you read this? All right. So notice this is the area to the right of the critical value, right? So the kind of problems we did last time are actually not the kind of problems you're going to have to do for homework. Why is somebody calling me right now? I love it. Am I shaking? Stop. Okay, thank you. So let's first remember how to read this. So let me ask you this. If I had a sample of 7 and I have alpha is 0.01, right? Alpha is 0.01, and this is a one-tailed test. How do I want to say this? All right. Let's see. Let me go up to the board, I think. Maybe, no, I'll just draw it on here. So the kind of test we're going to do, let's kind of do half and half here. The kind of test we're going to do, oh shit, I've got to plug you in.
Mode.
Thank you.
Bluetooth connect.
So the kind of problem we're going to do, first off, the distribution now looks like Jabba the Hutt, right? Okay, sorry. And the kind of test we're going to do, we did an example of this last time, right? Goodness of fit, which is really just seeing how well does a set of data fit an expected distribution. So we can either have like a uniform distribution expectation, or we can have some other kind of distribution, like a percentage of grades and how they fall kind of distribution. But the idea is, if the value I get is 0 for my chi-square, if the value was 0, that would mean no difference. So would that be evidence that there's a difference? No. So what's the idea then? I have to get so far away from what means no difference that it's evidence that there actually is a difference. So not only do I have to be different, but I have to be different enough. And that sounds just like a normal hypothesis test, right? If I think that the mean isn't really 11 and I get 10.96, is that evidence that it isn't 11? No, because I'm using a sample to talk about a population. And not only does it have to be different, it's got to be different enough. So if my alpha is 0.01 and my number in my sample is 7, what would this chi-square here be, this chi-square critical? It's kind of like the rejection region z-score. So this is equivalent to an upper tail test, to a right tail test. So there's 0.01 to the right. So what's the chi-square score?
16.812.
What's my degrees of freedom?
6.
What's my degrees of freedom?
6.
Are you guys out there? Am I hallucinating?
6.
Am I in my head right now?
It's
What's
7
happening?
minus 1,
Go
right?
ahead. What's the degrees of freedom?
6.
I see people unmuting and then not saying anything. What's happening out there?
Can you hear us?
6.
I can't hear you guys at all. Hold on. What
We're
happened? Why can't I hear you guys? Oh, I'm sorry. You're talking and I can't hear shit. Hold on. Let me take care of this. Hold on to Oh, I know what happened. All right, hold on. Everybody just give me a minute. I'm gonna have to redraw this shit. Hold on. I love this thing so much. All right, somebody say something.
It
hello.
was 6.
Shit. Why
Can you
can't I
hear us?
still hear you guys? Hold on to your butts. All right, what is happening with this? Hold on. Here we go. There we go. Somebody say something.
Hello.
6.
Oh, thank you. All right. Oh my God. Oh, geez. I got a little sound bar. I don't know if you guys have ever seen, it's like a little speaker. So I have to unplug that to plug in my little writing thing. And sometimes when I do that, it kind of like resets. So that was the worst. Okay, sorry guys. Let's see, what were we talking about? This is so exciting. This must be the way that a lot of your classes are. I'm kind of on the older side, but I feel like I'm decent with technology. So I can't even imagine what it's like. All right. So I was asking questions. You guys were all like, God, it's this. Can this guy hear me? All right. Let me try to draw that again. Weehaw. So n was 7. Degrees of freedom, of course, would be 6. And my alpha is 0.01. So what would this chi-square score be here? Go ahead.
16.812.
Dude! So let's see if that's right. 0.01. Degrees of freedom is 6. 16.812. Kick ass. This is the equivalent of step 3 in a hypothesis test. And you're all like, of course, step 3, Jeff. And that's the rejection region step. So this sets up how far away a sample has to get to show evidence that it doesn't follow the distribution I'm given. The other chi-square, what would be sort of like Z star, this is the formula we use for it. All right, let's see if I can remember this. All right, that wasn't too bad, Jeff. Yay. All right, and then we can compare. We can say, okay, this is how far I needed to get. And then I can just see what this is and see if I got far enough away. So let's come back to that handout. For goodness of fit, by the way, it's always going to be these. Goodness of fit is always going to be far away. It's always going to be like a right-tailed test. It's always going to be over here for goodness of fit. All right, so let me clear this away. Let me come back to my, let me see, where did you go? Oh yeah, I got to go back to it. Scheisse. So if you guys, let's see. Today, there we go. Here it is. So looking at this bad boy, I give you one that's worked out. And the one I give you that's worked out is exactly like the one we did last time. Do you guys remember? We had the M&Ms. I don't think it's the same numbers, but it's the same kind of problem. And see, this one said I had to be more than 11.071, but my chi-square came out to be just 3.143. So the sample is different, but the sample isn't different enough to be evidence that the whole population is different from being uniform, right? All right, so here's the other way we could be given information. Blood levels, blood cholesterol levels for the general population are distributed thusly. Ooh. We find a group of 500 people living in a secluded area, eating a certain diet. And hopefully this isn't like the hills have eyes people. If you don't know what that is, then that's probably for the better. Somebody knows what it is. All right. I don't want to mimic their diet if this is true. Can you guys tell what I put in the observed column?
Nothing.
Say again, sorry.
Right now it's just empty.
It's empty, but what will I put in the observed column?
The data found.
Yes. So this data here. So the observed has to be told to you directly. It's the expected that you're going to have to calculate. So just to get you guys started, for example, here I would put 132 because it tells me I have observed that 132 have a level below 130. So you can keep going. This column is going to be easy. This column is going to be a little bit more interesting. I expect them to follow this. So first fill in this column and then we'll all compare answers. See if we all got the same answers.
Would we make that column a percentage or no?
Which column?
The observed column, because in the top.
No. What you're going to do is you're going to do the opposite of what you're saying. You're going to take 20% of 500 people to figure out what goes here. All right, so this first column is pretty straightforward. And then I do this evil thing here. Shit, what is that? That'll be 320, 452. So is it 48 down here? Is that right?
That's what I got.
You're coming for me. All right. And of course, you can just take a quick second, make sure that adds up to 500. Now, the expected, if they follow this, assuming they follow this, how many would I expect to have below 130? Well, I would expect 20% of 500. And what's 20% of 500? 100. It's crazy. Thank you. And then 30% of 500. $150. That's right. Is everybody seeing where these numbers are coming from? Don't say chat. I see them. They're coming from chat. They won't always come from chat. And then of course 30. Sorry, go ahead.
So for the first one, it's 20% of, you said 500?
Because there's 500 total people. That's right.
Yeah, so you're multiplying 0.20 times 500.
That's right.
Cool.
So what about 200 to 240? What goes here?
175.
175 sounds about right. And then greater than 240?
75.
75. Okay. And then you take a quick second. You can kind of check yourself, make sure these add up to 500. Obviously, they have to because we only have 500 people. So if they don't, you did something wrong. You guys doing okay out there? Aw, Jeff, why are you doing it this way? So the problem we did with the M&Ms, let me make this distinction. There's only two possible problems. It's either I tell you the percentages, like the one we're doing now, and then you have to step by step calculate the expected for each category, or I tell you it's a uniform distribution is the expectation, in which case you just divide how many you've got by the number of categories. They all get equally distributed, uniformly distributed. Okay, maybe. So then here, I would just do 132 minus 100 squared. So 32 squared is 964. Is that right? Nobody's gonna help me. You want to see, let me do this. Let me show you what this looks like in the calculator. Yeah, it could be 1024. I don't know what I'm doing. 30, 966. Oh, I should have added one more 60. Oh, well, that's what I get for trying to do it in my head. So 1024, that sounds better. All right, let's hold off on the calculator for now. Everybody understand what's happening? You guys okay out there? You guys are all working. I like it. So observed minus expected. So that'll be 219 minus 150 is 69 squared is something. 4,900, 4760, 4761. I lost track.
4761.
All right. And then observed minus expected, you get 74. Did you do 74 squared, Jeff? I will. Will I? 285, 60, 50, 460. Oh, I lost track. 5470, 5476. I don't know. I'm guessing on that one.
Yeah, this is 5476.
And then 48 minus 75 is 27. Squared is 729.
Yes.
That one I memorized. I can't take credit for that. All right. See, isn't that amazing, kids? Wow, Jeff, do that at parties. All right. I got most of them right. I guess I can keep my job. And then, oh yeah, I don't have to do anything with this. You don't have anything here. I got to do one more thing. And now I really want this to make a lot of sense. If these were the same, then this whole column would have been 0. It's the fact that these are different. And I'm kind of collecting those differences here. But then it has to be a relative difference. Relative to how big these are, what was the difference? I mean, so it's got to be a relative difference at the end. Because if two things are 1,000 apart, but we're talking about numbers in the trillions, that's nothing. But if we're talking about somebody's date of birth and we're 1,000 years off, that's bad. So I don't know. So now you just got to divide each of these by the expected. So this first one's easy. And then it gets a little bit harder. Yeah, I'm not going to try. I'll burst a bubble.
31.74.
31.74, is that right? Jeff, you made this one crazy.
31.3.
31.3?
And 9.72.
9.72. So when you add up all these, that will be our chi-square. It's sort of like Z star. It's our sample chi. Really, Jeff? Why are you doing that in your head, dude? You're going to hurt yourself. Somebody do that for me before
I got 83.
83.
83?
Yeah, 83.
Exactly?
Yes.
Neat. All right. That's unexpected. That's trying to be 83. Poor little dude. Now, we're sort of doing this problem backwards. I didn't set up my rejection region yet, right? But that's okay. I mean, we normally want to jump into the stuff. Now let's go back in time. 0.01 level of significance. Does somebody remember how to get the degrees of freedom here? It is definitely not 499. What's my degrees of freedom?
3.
Yeah, there's 4 categories. So 3. I love the fact that it's officially K-1, like they forgot how to spell category. So for a goodness of fit test, the degrees of freedom is the number of categories minus 1. So if you look at your chart now, which I can't show you, which really sucks because I can't see it either. Good job, Jeff. If you look at your chi-square chart, alpha is 0.01, degrees of freedom is 3. Can you see what your chi-square is going to be for your ejection region? Somebody's telling me 11.345. Do you guys concur? Do you guys concur or do you cur? Do you cur in the first place? Okay. So that means that my little Java, how far in his tail did I have to go? I have to go 11 point, what was it, 345?
Yes,
Did we make it
11.345.
Yeah, did we make it that far? We blew this thing out of the water. I mean, we got to freaking 83. We're over there. Are we far enough away from 0 to say that these are different? So remember, 0 means no difference. We have to get this far to show a difference. We blew it out of the water. So, and yeah, that is how I say water. Yes. We sure as all hell did. So how can you say your answer? You can say we have found evidence that these are not what we expect. In fact, can I go one step further? Can you guys see that these cholesterol levels are better than what's expected, better than the general population? I think everybody understands that higher cholesterol levels are worse, right? So fewer of them had higher levels, more of them had lower levels. So whatever diet these people are eating would be interesting, or the water, or the air, or the genes, or anything really. This is what started the Mediterranean. Do you guys remember, anybody know about the Mediterranean diet? And people were just guzzling olive oil. Oh, they eat olive oil. So they eat all their shit, their Whoppers and their shit, and then they would just guzzle olive oil, basically. I mean, that's not going to help you. My God. They also walk more. They do more exercise. They also eat more raw stuff and cleaner stuff. And holy shit, there's so much more than just, but of course, we're American. We want to say, oh, that's easy. There must be that. Anyway, sorry. They keep coming down on us, but too bad. Do you guys get the idea of this? It's a new table. It's a new formula, but it isn't that evil. It feels very familiar to some other things we've done.
Sorry, I think I blinked and I missed it. When you're figuring out the like
this guy?
Yes. So
yes,
you're using the degrees of freedom that we got, and then the level of significance that it gives you in the equation or the word problem.
yes.
Okay, got it. Thank you.
So if you go to 0.01 and you go down to 3, you'll see the 11.345. So again, here we would say we have found evidence. My God, Jeff, what word is that? We have found evidence that their blood cholesterol is different. Bam. And actually, we got a little more specific. The test only says they're different, but then we can look at the actual data and say, oh, it's different in the better direction. It's better. It's not just different. We can be more specific. It looks like it's better. So then we want to go in a more detailed test. Is it their genes? In which case we can't do much. Is it the water? Is it the food? Is it their exercise? Right? Is it some mystical, magical stones in the middle of town that gives them this? Who knows? We'll send Indiana Jones in there and they belong in a museum. All right, stop. You guys doing okay out there? So this isn't nearly as horrible as some of the other stuff we've done, right? And you can do a lot more with chi-squared distributions than what we're doing with them. I think you guys probably can pick up on that. Let me see. Let me clear all this. I'm going to clear all my writing. Has everybody got what they want from up there? So there is a problem like this on the practice final you can try out. Let's look at that practice. Oh, sorry, go ahead.
On the quiz as well, or are we going to do more stuff from the other worksheet that we were working on earlier?
What's the other worksheet? Sorry.
Sorry, we were looking at the correlation with bachelor's degrees and then income. Is that going to be more like the quiz that's coming up?
Yes, the quiz is on chapter 12.
Okay, thank you.
You're welcome. Let's see. So let's look at this real quick. Good old practice final. So I'll tell you what, I mean, I don't know if you guys understand this or realize this, but we basically just finished. There's no more new stuff. So what I'm planning for Wednesday is to devote our time to, any questions about the quiz, because the quiz is going to be on Wednesday. Any questions about goodness of fit stuff, because that's the most recent stuff. And then jump into the practice final and maybe try a few problems out together. I plan on having the solution video up by Monday's class. So we effectively have like 2 days worth of final exam review, Wednesday and Monday, which is awesome. You guys have done a stellar job. You're my best retaining class, meaning I have the most students left in this class than my other 2 classes. And we somehow have gotten through everything 1 day faster than I thought we would, which is kind of insane. And maybe some of you guys are like, yeah, we can feel it, dude. All right, Speedy, slow down. But, you know, I think I slow down when people ask questions. So you're going to want to focus primarily on homework. But if you're pretty good up to homework, you can start looking at this bad boy. Start giving them a try. You could try, you know, the very last problem is a problem like what we just did with the percentages for the chi-square kind of problem. Let's see, what else do I have on here? I got some hypothesis tests. I've got some, oh yeah, I want to talk about this real quick. Have any of you guys ever heard of Bronx Pizza down in Hillcrest? No? Last time I had it, it wasn't quite as good. It's still damn good, but let me tell you, when I lived down there, no, the final won't be quite this long. When I lived down in Hillcrest, what was I was this data point right here. This was me. I lived 1.5 miles away from Bronx Pizza, and I weighed 216. Right. So I'm not trying to blame Bronx Pizza. I thought this was kind of a funny thing to make. So that was the only true data point in that table. Since I moved away from Bronx Pizza, I've lost 16 pounds. So, you know, a little bit over 16 pounds. Maybe there's a correlation there. I don't know. But now I live closer to D'Amato's Pizza in La Mesa, and that's damn good. So I'm probably going to go back up. So we'll see. So you can try that problem out. Let's see, blah, blah, blah. Yeah, and hopefully the stuff looks, remember the stuff? Remember the stuff here? XP of X stuff. And look at this probability stuff. Oh, you remember that? All right, and here's the correlation coffee. There's a correlation coffee. No, I'm sorry. There's just a problem about coffee. Let me see. What do I have here? Thank you. So yeah, the actual final, my finals are somewhere in the 20s, like maybe 24, 25 problems, counting A, B, C, D, right? I hate when a teacher says there's 4 problems and they all have A through J, and you're like, that's not 4. Math boy, learn how to count. All right. So this is probably a little bit longer than the actual final is going to be. So, you know, I obviously am not going to be able to test you on everything. So what exactly will it leave off? You'll find out when you see the final. It's crazy. So what do you have to study? Everything. I like it. So I tell you what, unless there's any questions, we're done already. I mean, if anybody wanted to ask something specific from more recent sections or something, I have lectured over everything. We are done early with this class. So on Wednesday and Monday, we'll focus on final exam review. And on Wednesday, we'll focus a little bit on, of course, if anybody has questions about the quiz. Yes, formulas will be provided. Good question. All right. I'm sure you guys can't believe this. I mean, it's only 2:30, but I'm fine with it because I haven't had lunch yet. I'd like to have some of that. So does anybody have any questions, or are you guys just hanging out just in case? What's happening? You guys understand that class is over?
I have a question.
Yes.
For when we turned in the homework, when we sent in the picture for the graph, was that fine? Like, is that the way you want us to send it in, like for the test?
Yes, exactly.
Okay.
So I'm going to be grading homework this afternoon and tomorrow. Hopefully I get enough of it done tomorrow. So you have that to look at before the actual quiz. Yeah.
Okay. Have a nice day.
You too.
I had a question about when will we find out? Like, you know that thing that you were gonna show us, like what we need to get on the final in order to.
Oh yeah. So as soon as I grade this quiz that's happening on Wednesday, I'll update the grade book on Canvas.
Okay, thank you.
So just put that last grade in there before I talk about, because then the final's the only thing left.
Okay.
Yep.
I have a question.
Yes.
So for the quiz, this Wednesday, is it okay if we can, like, when we create our scatter plot, can we like do it by hand, or do you want us to like send a screenshot of what we got in the calculator?
I want a screenshot of your scatter plot with your line of best fit in the calculator.
Okay.
Yeah.
All right.
All right. Everybody else okay? I'm gonna head out. Oh,
I have a question.
yes.
Can you go over a homework question with me?
Yeah.
Section 12.5, number 72.
Yeah. Sorry, everybody. That was the big question.
Okay, I missed it.
So one of the first things that goes wrong, just to see, they tell you use stories as the independent variable. So that makes
Okay.
this X and this Y. So you'd actually have to make this, the stories L1 and the height L2. If you didn't, it's okay, but it's not going to match up with the answer keys equation of the line. Does that make, I don't know if that's part of the problem.
No, I'm on G and H where I'm starting to
Okay.
get.
G is more of a subjective thing for us. So if you look at your scatter plot in the line of best fit, what would make something an outlier? If you have your line of best fit drawn?
Well, I was like, it has to be so far away from your line, right?
Good.
But it's
Yeah,
hard
exactly.
for me to tell because they all look pretty close. So whichever
Okay.
ones are the farthest away are an outlier, or does it have to be
there could be,
significantly?
like, the answer can be no.
Okay.
Yes. And then H, we were talking about that earlier. Do you see how your stories data goes from 22 to 110?
Yeah.
So the line you calculate will only work for certain between 22 and 110 stories. And this one says 6. That's
Okay.
not inside of my data. So I didn't calculate a line of best fit that includes the idea of 6.
Okay. Because I was
That's
thinking
why I
when
asked this question.
when
Yeah,
you
go
were
ahead.
showing us today how you can do
Yes.
what is it, second value,
And it
and you
didn't
can
work,
put
right?
in 6. I didn't try it yet, so I was like, well, maybe that's the answer for that
It won't work.
question. It won't work.
It won't. It probably won't work because it only works for things that show up on the screen. So if you do zoom stacked, 6 won't even be on the part of the x-axis you can see because it doesn't include 6.
Okay. I wasn't
So
sure if you wanted us to like adjust the graphs
Yeah.
to include everything and then
They're going to
find where
want you
6
to.
is.
I'm really curious about this problem. What happens when you put a 6 in? I'm curious if you get something completely that doesn't make sense. But the answer to that really is you can't even officially use it. You can't
Okay.
even officially use the line of best fit because that's outside of the range. Yeah.
Okay. That's where I was getting confused. Okay.
Cool.
Thank you. Thank you.
You're welcome. Everybody else okay out there? If you're there? All right. I'm gonna head out.